Okay, this is a video showing my findings for MZU-6 building number 2. Here I'm showing real time, the web control for today, May 21st. This is 3:28 in the afternoon. Outside conditions are 60.5 degrees Fahrenheit. And what we've been seeing with this building and what we've been focusing so far is on the first floor in this specific room right here, which corresponds to terminal unit 1-8, room 129. I'm going to click on there and we're going to see that we're never able to meet our effective heating set point of 69. This room is always running a little bit warmer than it should be. Currently the room temperature is 73.9 degrees Fahrenheit. We have a set point temperature or supplier temperature rather of 71.9 degrees coming in there. The damper position currently is 69 or 70% as it just changed open. So we discover that this damper right here is the one that is driving for sure the entire pressure or static pressure set point for the AHU system. Anytime that we have this damper opening wider and wider and wider all the way to nearly 100% to maintain an airflow of about 145 to 150 CFM, as it continues to open when the static pressure is lowered, this triggers a signal for static pressure reset to be raised again. Static pressure gets raised again, so this damper begins to close and close and close until it reaches a point where it has again only 145 to 150 CFM, but because it continues calling for the same amount of cooling that it needs, or it keeps asking for air trying to reach this temperature that it needs, it triggers again the static pressure to go up and on. So the static pressure continues to go up and down, which we have seen in the trends. Right now, for example, just to show that, we have that this damper is open now to 73%, so it's opening higher and higher. If we go and see the trends right now into the trends tab, and we let's go see them from the mechanical room. We will go to okay, I'm going to close here graphics. We're going to go to mechanical room, MZU-6. We are going to see the trends here, and we will see that for static pressure control, currently we are on the downward slope. So currently our static pressure is resetting from 1.1 where it was downward towards 0.83 that it is currently 3:25 p.m. and this corresponds with that damper opening wider and wider or bigger and bigger every time to allow more air in because the static pressure is lower. So that we discover for sure that room is the one that is handling, or the one that is driving the bus, as Bruce says, in regards to what is the static pressure for the duct. However, we discover something very interesting, and that is that this room right here, which is serviced by terminal unit 1-1, currently has a temperature of 70.6 degrees, so it runs cold. This whole area, it's served by the same terminal unit. Any which one of these, including this room right here, will still refer to terminal unit 1-1. And this terminal unit 1-1, it's open always at 100% for reheating, even though the damper position is actually lower or smaller, the amount of flow that we have. We have an effective flow of 276 CFM, which is close to the airflow maximum of 300. The room or zone temperature is only 70.6. There has been no adjustment to the set point. And the temperature, the discharge temperature, supply air temperature from this terminal unit is 83 degrees Fahrenheit. So we started speculating what could be happening with this valve. Is there a problem with the valve, or is it a problem of where we have the thermostat position? Because if we have this terminal unit blowing air into this room, but we have our thermostat in this room, we are not ever going to have this thermostat reading correspond to what the real temperature is in some of the other rooms. This is also the case here for room 128, which corresponds to these two that seem to be divided by a wall. And again, we have here the valve is only open to 8% in this case, but there is heating being called for this room. So we have several rooms calling for heating for sure. But the main one, I believe, is this one, triggering the system to have this higher temperature. The set point, however, for the temperature for the entire MZU-6, if we notice here, we will see that the actual set point, the actual set point is 0.8 for the static pressure, but for temperature, the supply air set point for heating is 53 degrees Fahrenheit. So the heating, they have tried to adjust it so that it would be 53 degrees Fahrenheit, but the unit is still not reaching that. We're still having air circulating coming from the return air over here, 72.1, and going out supply air at 72.4. Now I started looking more into this, and I realized that we have this here, which is actually our reheat system. Sorry, it's this one right here is a reheat system. And when I looked into the reheat system, which is operating right now, I understand that this is what's heating our water to serve the terminal units. If we follow the pipes, we can see that this goes out to terminal units. Here's how hot the water is right now, etc. When I looked into the logic for that specific reheat system, I found out that the running condition currently it's on, and the running condition it's on, even dual MC6, it's not requiring heat. It is actually being overwritten right here by this block, which I am unable to see anymore other than this page. And all it says is that it's a binary output, that it's set to yes. So somehow there is an override here that it's turning our heating for MZU-6 on, and that is determining that hot water that's there, that's being sent. Also, I notice here that it has been running, it has been on, overwritten on, according to this block, since, you won't see it on there here, on. Details, okay, change of state was set to on back on 10 o'clock in the morning, or 10:07 in the morning on 4/17/2019. So 1 year ago this was manually set to on, and then it has been going like that since then, at least according to this block. I still believe though that one of the biggest culprits for why the room is not reaching, for why the system is not reaching the set point, it's because there is something going on with this specific terminal unit that has always this valve open at 100%, and so we're going to have always a 300 CFM flow of air roughly at 82 to 83 degrees Fahrenheit, which again, because we're not sure at that level exactly which one of these rooms it is, and I have not investigated yet with the mechanical drawings, but we have all these different ones here that are all being served by the same terminal unit. We have no way of knowing where the terminal unit exactly is and where the thermostat might be. But this might be one of the main reasons why this other room and terminal unit 1-08 is never able to reach the set point that it has of 69, because our overall set point for AHU MZU-6, it's always going to be higher, the actual temperature, than the set point. So we're never going to be able to meet that if we have high amounts of air, like 300 CFM up here at 80 plus degrees Fahrenheit blowing in there. That's all that I have for this right now. Thank you.